This is the screencast for section 2.7, example 1. So now we're going to solve some equations with rational expressions. We have an equation, so the left side will equal the right side as long as you find the two x values that make them equal. So first we have our method that we're going to use is clearing out fractions. I've got a denominator in this equation that has an x in it. So instead I'm going to multiply everything by x. Now I am clearly going to show my grader, me, what I am doing with every single step. So now I'm going to take the denominator and multiply every single term by x, that denominator, which gets me x squared. Now these x's cancel, so plus 3 equals 4x. Now I can set this equal to 0. I can factor, so I have x minus 3 times x minus 1 equals 0. So I think that x equals 3 and positive 1 will make the left side equal to the right side. Now, we have been working with the calculator a lot in checking our work by graphing the left side in y1, the right side in y2, and finding the intersections to see if we actually got an intersection at x equals 3 and x equals 1. Well, what if you weren't allowed to use your calculator? Well, like we said, these are the x values that should make the left side equal to the right side. So I'm going to check those out. I'm going to try plugging in positive 3. So 3 plus 1 should equal 4. It works out. I checked it. I made sure to prove by showing every single step that 4 does actually equal 4. So 3 makes the left side equal to the right side. Now I'm going to try positive 1. And again, by showing every single step of my simplification, making it very obvious to my grader, I showed that both 3 and 1 do make the left side equal to the right side. I checked my work, and I am positive I am right. The now try problem for example 1 is number 1. We're going to solve this equation algebraically, support our answer numerically, and identify any extraneous solutions. Oh, does that sound familiar? Extra solutions? We have to make sure that we are verifying that each solution we get after we solve is actually a solution. We don't have any extra ones laying in there that are not going to make the left side equal to the right side. So I see a common denominator of 3. So I'm going to take the original function, and in order to cancel out each of those denominators, I'm going to multiply every single term by the same thing, which in this case will cancel out each one of those denominators of 3. So I get x minus 2 plus x plus 5 equals, and then 3 times a third is 1. Now I can simplify. I get 2x plus 3 equals 1. Subtract 3 from both sides. 2x equals negative 2. Divide both sides by 2, and I have one answer to check. X equals negative 1. So off to the side, I'm going to put, let's see, negative 1 minus 2 over 3 plus negative 1 plus 5 over 3. And that should equal 1/3. Negative 1 minus 2 is negative 3 over 3. Negative 1 plus 5 is 4 over 3. Let's see. Negative 3/3 plus 4/3 is, in fact, positive 1/3. Let me move this again. So now I've got 1/3 equals 1/3. I've checked it. I'm right. Negative 1 does make the left side equal to the right side. It equals 1/3, but that doesn't matter. It just matters that the left side does in fact equal to the right side.